Welcome to qnawire.
In this question, we are given this setup. So initially, we have a horizontal air track, and then there's a glider, and then on the glider there is a pendulum, and initially this is they are at the center. Okay, and then a force is pushed onto the glider. Yeah, and then we are also given that the pendulum is mass m. The glider is also mass m. Okay, and then after some time, the force pushes the system. So I'm going to denote this as the initial position of the glider. And after some time, the glider moves some distance, and this is x1, and then the pendulum would move just before the force is removed. The pendulum would swing in this manner. So so this is our x2. Okay. Yeah, and x1 and x2 are measured from the initial position to the center of that object. Okay. Yeah. So in part A, we want to find the horizontal component of the VCM, of the glider sphere system. Okay. So to do this, first we want to find XCM. So this is m1 x1 plus m2 x2 divided by m1 plus m2. Since m1 and m2 are the same, so xcm will just be half times x1 plus x2. Okay, then we also want the ACM. So from Newton's second law, okay, so F net equals to the total mass times ACM. Okay, so this gives ACM equals to F over 2m. Okay, then we'll be using the kinematics equation. So V final square equals to Vi square plus 2a delta x. So A is our ACM, delta x is our XCM, and then Vi is 0, so V final is our VCM. Okay, VCM square equals to 0 plus 2 times the ACM, which is F over 2m. The delta x is half x1 plus x2. So simplify. Okay, we get VCM is equal to F over 2m x1 plus x2 square root. Okay, so this is the answer for part A. Then we move on to part B. In part B, we want to find an expression for the largest angle the chord makes with the vertical, meaning we are interested to find this angle. Okay, yeah, for the largest angle. Okay, so to do this, I'll be using work energy theorem. So the work done by force is equal to the Ke of the system plus the vibrational energy of pendulum. Okay, since the force is exerted on the glider only. Okay, so what this means is that the work done by force will be F times x1, and then the KE of the system will be half times the total mass, which is 2m times VCM square, plus E vibrational. Okay, so the VCM square is something that we found previously, okay, which is F over 2m x1 plus x2, and we can see that the 2m cancels out, and so we found that our E vibrational is F over 2 x1 minus x2. Okay, then at the largest angle, E vibrational only has gravitational, potential energy. So the kinetic energy is 0 because it is at the turnaround point. Okay, so the gravitational potential energy is given as 1 mgl times 1 minus cosine theta, and then this is, you equate this to the E vibrational, and so cosine theta will be rearranged. Yeah, this is what you get. Then theta will just be arc cosine 1 minus F over 2 mgl x1 minus x2. Okay, so this is the expression for the largest angle.